So in the last class, we have seen what is green chemistry, what is the need for green chemistry, what are all the objectives of green chemistry, and what are all the 12 principles to be followed so that the objectives of the green chemistry can be met. So in fact, we have listed out all the 12 principles. So in this class, we will see in detail about the first 4 principles. So the first principle is prevention, second principle is atom economy, the third principle is less hazardous chemical synthesis, the fourth principle is designing of safer chemicals. So regarding the prevention is concerned, just like prevention is better than cure, so we should prevent the formation of waste in green chemistry. So if we prevent the waste, there may not be any need to treat them. So we need not have the manpower, machine power and money. So all this can be prevented if we prevent the waste in the beginning itself. So how to compare the process, which process generates less waste and which process generates more waste by a common factor which is called the E factor. E factor is nothing but it is a ratio between the amount of the waste generated in the particular production process to the amount of useful product formed in that particular process. So this is the factor which is used to compare all the process, and we should see to develop zero waste technologies. So the methods available to generate less waste are: one, through reaction choices, second one through process design, third one by recycling. So the same product can be manufactured or prepared by several routes or several synthetic schemes. Each and every route we should analyze carefully, and we should see to that in which process the wastage is more and which is less, and we should choose the process which generates less waste, and it should be placed appropriately in the production process. Now let me tell you another factor which is called yield, that is, which compares the amount of product formed and the expected amount of the product to be obtained in that particular reaction. So let us see with an example. Phenol can be prepared from benzene, sulfuric acid and sodium hydroxide. Of course, this is not in one stage. It can be prepared into 3 stages. The first stage, benzene reacts with sodium hydroxide to form sodium phenolate, and the sodium phenolate is subsequently hydrolyzed with sulfuric acid to form the phenol. So in this process, say the phenol molecular weight is 94 grams. So normally as a chemical reaction, 1 mole of reactant should give 1 mole of the product. In that sense, the molecular weight of benzene is 78 and the molecular weight of phenol is 94. So if we take 78 grams of benzene, the expected product yield, it should be 94 grams. So in this reaction, the other products are sodium sulfite and water. So in the same process, with 94 grams of phenol, some 126 grams of sodium sulfite is also expected. So here how the yield can be calculated is, in this, if we perform this reaction, suppose if we get 77 grams of phenol, then the yield will be equal to 77 grams divided by 94 into 100. Roughly it works out to be 84%. So 84% yield for a reaction is quite good. But what we should look into it is, here in this process 126 grams of sodium sulfite is formed as another product. If we can able to use it as a byproduct, so in some other industries it is well and good. Otherwise, 126 grams of sodium sulphide becomes a wastage. So we should take care of that. So normally industries accept, that is, the waste product or a byproduct of one industry, it will go as a raw material in another industry, or if it is generated in one area in the same industry, it can be accepted in another industry. We will discuss with some more examples. That is, the biomass or the bottom mass which is generated in the thermal power stations, that is, after burning of the coal, the left out mass, we call it as the bottom mass, and that is used as a raw material in the brick and cement industry. Likewise, the effluent water which is coming out after the cleaning of machineries, that water can be used as a coolant water in the thermal power stations. Similarly, the municipal waste, that is, it is a source of energy. So if we consider the waste as a source of energy, then as a liquid fuel, that is, the waste solvents which are obtained from the paint industry, the adhesives, then varnishes, then inks. So these solvents can be used as a liquid fuel in the cement industry. Likewise, as a solid fuel, the shredded pieces of carpets or plastic materials or paper, so they can be used as a solid fuel in the cement industry. So likewise, that is the byproduct generated in one reaction. If we can able to use it in another reaction or in another process, it is well and good, and it is suitable for us to have a safe environment. Okay, now let us see the second principle of green chemistry, that is atom economy. Here we are arresting the waste in the molecular level itself. That is, we should see that is, what are all the reactants we are taking, it should completely go into the product. So what are all the atoms present in the reactant, it should end up with a product, so that no waste is generated. So it is a reasonable measure to compare the reactions as far as the green chemistry is concerned. So let us see with an example. So once again, we will see an alternate method for the preparation of phenol. So here, benzene, it reacts with propylene in presence of oxygen to form phenol, and the byproduct here it is acetone. So benzene, it reacts with propylene initially to form isopropyl benzene, otherwise known as cumene, and subsequently with oxidation it gets converted into phenol. So ultimately these are all the reactants, and the products are phenol and acetone. Here the molecular weight of phenol is 94, whereas the molecular weight of benzene is 78. Further, here we should take the molecular weight of oxygen 32 and propylene, that is 42, into consideration. Likewise, on the other side, the molecular weight of acetone is 58. So if we calculate, so totally, that is, what are all the atoms and the corresponding molecular weight of the reactants, it comes to 152 grams. And similarly, if we see the product, the sum of the molecular weights of acetone and phenol put together, it comes to 152. So in the calculation of atom economy, how it is defined is, it is the ratio between the total molecular weight of all the products divided by the total molecular weight of all the reactants which are taken in the reaction into 100. So for this particular example, if we see what is the atom economy is, the total molecular weight of the products is 152 divided by the total molecular weight of the reactants is 52. So 152 by 152 into 100, so it works out to be 100%. So the atom economy is 100%. So 100% atom economy for a reaction is very beautiful. So we should consider this as far as green chemistry is concerned. So while considering atom economy, so carefully it has to be noted in some reactions the atom economy may be 100%, but the reaction yield it will be less. If the reaction yield is less, then once again the waste will be more. So normally this atom economy we are considering it in the planning stage, but whereas the yield we are considering it after the completion of the reaction. That is, after executing the reaction we calculate the yield. So as a better choice, it is better to consider both atom economy and the yield so that we can safely arrive at a conclusion while taking decision which reaction is suitable. Now the third principle is less hazardous chemical synthesis. So when we do a reaction, we should carefully see to that what are all the reactants we are taking for that reaction. It should not be a hazardous substance, or if at all we should take less hazardous substances. So let us discuss this principle with some examples. Say you would have heard about polycarbonates. Normally polycarbonates, they have very good optical properties and they have very good strength also. So if we use polycarbonates, normally the polycarbonates are synthesized from bisphenol A. That being one of the reactants, the other reactant is either carbonyl chloride or diphenyl carbonate. So let us see the first process. When bisphenol A, it reacts with carbonyl chloride, the carbonyl chloride is otherwise called as phosgene. It's a poisonous gas. Not only that, that carbonyl chloride is prepared from carbon monoxide and chlorine. Both of them are poisonous gases. So the entire process becomes an hazardous process. On the other hand, if we react the bisphenol A with diphenyl carbonate, this diphenyl carbonate is prepared from methanol, then oxygen and carbon monoxide. Initially it forms dimethyl carbonate, subsequently that reacts with 2 moles of phenol to form diphenyl carbonate. This diphenyl carbonate is less hazardous substances. So automatically this synthetic route, that the bisphenol A reacting with diphenyl carbonate, it becomes a less hazardous route and it will preferably chosen as the production process. The fourth principle is designing of safer chemicals. So in the previous principle we have seen we are supposed to take less hazardous raw materials, but in this principle we are enforcing the same to the product. Whatever product is formed in that particular reaction, it should be a safer material. Not only that, the waste whichever is formed, that should be also non-toxic to the environment. So once again let us discuss this principle taking some examples. Say let us talk about polymers. Everybody would have learnt about polymers. That is, the polymers, they are very tough and they are resistant to cracking and breaking. So normally safety point of sense, if we consider, we should see two aspects. One, the flammability part, it should be non-flammable, and at the same time the environmental impact, it should be less, it should be biodegradable. So if we think in those lines, nowadays the polyphenyl sulfone is considered as a safe polymer and can be used for various processes. Then yet another example in this line is, let us talk about the detergents. So normally we use soaps and detergents for washing purposes. Soap, that is sodium salt of higher fatty acids, which is safe to use when we use soft water. But when it comes to hard water, soap doesn't give lather. So automatically that is we prefer detergents. Detergents are nothing but alkyl benzene sulfonic acid salts. So here alkyl in the sense it is branched alkyl portion. So branched alkyl benzene sulfonic acids, either sodium salts or the potassium salts, when it becomes branched alkyl chain, they are non-biodegradable. So but when it gets replaced by linear alkyl benzene sulfonic acids, now linear chains, that is, they are biodegradable. So nowadays enough efforts has been made to prepare the linear alkyl benzene sulfonic acids, so which will be biodegradable and more suitable for the environment. And yet another example that is in the same line to the detergents, another ingredient which is usually called as a builder is sodium phosphates. These sodium phosphates are added into the detergent to remove the calcium and magnesium ions, so that to a certain extent the hardness of water can be removed and the detergent ingredient can work well. This sodium phosphate, unfortunately, it is non-biodegradable. So in order to prepare environment friendly detergents, nowadays zeolites, that is aluminum silicates, are being used. So once again, to explain you with one more example, let us talk about the insecticides and the pesticides. India being an agricultural country, we depend on the agricultural products. Nowadays it is almost impossible to prepare the agricultural products without insecticides and pesticides. Normally phosphorus and chlorinated compounds are used as pesticides, but unfortunately these compounds are non-biodegradable. So to quote an example, DDT, it is not at all biodegradable, even it has been seen in polar bears. So nowadays efforts are being made to prepare pyrethroid pesticides. These pyrethroid pesticides, they are degradable, and not only that, when it gets exposed to sunlight for 2 to 3 days, automatically that is the decomposition takes place, and at the same time it is less harmful to the human beings. So let us come to the end of the today's session. So in this session we have seen the first 4 principles of the green chemistry, that is the prevention, atom economy, user-friendly chemical technologies, and designing safer chemicals. Hope you understood well, and we will see in the next class about the next 4 principles. Thank you.